Okay, let us talk about analytical synthesis of 4-bar mechanism with 5 accuracy points and function generation. Okay, now it is analytical synthesis and 4-bar mechanism. So the starting point is going to be Freudenstein equation, and that equation, if you remember, was of this form: k1 cos I think phi or theta, probably phi I plus k2 cos theta I plus k3 equals cos theta I minus phi. Okay, this is Freudenstein equation. Now it looks like we have only 3 design parameters here: k1, k2, k3, and previously we did 3 accuracy point synthesis based on this. So you have theta 1 phi 1, theta 2 phi 2, theta 3 phi 3. You just plug them, you get 3 equations and 3 unknowns. There are 3 accuracy points. Okay, but now for 5 accuracy points we'll have to introduce 2 more design parameters in this. Okay, now so you cannot take see theta 1 phi 1, theta 2 phi 2, in this way up to theta 5 phi 5. Okay, if you specify like that, then you will have 5 equations and 3 unknowns, so that you cannot have 5 accuracy points. Okay, you can do a synthesis using that least square technique. We talked about that previously, but you cannot have 5 accuracy points. Okay, now to introduce, you can pause this video and think just like what we did for the slider crank mechanism. How can we introduce 2 more design parameters? You can try to think about it, but the answer is just like we did for slider crank. You can write theta I equals theta 1 plus theta 1I, and similarly phi I equals phi 1 plus phi 1I. Okay. And what is specified in the problem is theta 1 theta 1 2 1 3 1 4 1 5 and phi 1 2 1 3 1 4 and 1 5. Okay, this is what is specified. So you have, see, 5 accuracy points. This will be called 5 accuracy points. But now this theta 1 and phi 1, okay, these become your additional design parameters. Okay, so we can plug them in the Freudenstein equation. So instead of phi I, you will write phi 1 plus phi 1I. Okay, and phi 1 1 will be 0, phi 1 2 is given, so like that. And theta I will become theta 1 plus theta 1I. So in this way you just modify this equation, and then this equation will have actually 5 unknowns: k1, k2, k3, theta 1 and phi 1. Okay, 5 unknown will be here: k1, k2, k3, theta 1 and phi 1, and you will have 5 equations. Okay, as I goes from 1 to 5. Okay, so you'll have 5 equations, 5 unknown, and you can solve them. So that will be 5 accuracy point synthesis. Okay, that is the general idea. The number of accuracy point is equal to the number of design parameters, and we introduce additional design parameters in some way so that we can do the synthesis. Okay, now let me ask you the question, is it possible to do 6 accuracy point synthesis? And answer is no. Okay, because this is the minimum you'll have to specify. uh, uh, so you cannot introduce another actually design parameter in these equations, so you cannot go beyond 5 accuracy point synthesis. If you want to read in detail about this one, this is given in section 10.8 of Dannewitt-Hartenberg book. It says crank and follower synthesis 5 accuracy points. So you can see they introduce these additional design parameters, and then you get 5 unknowns. And let us see, they don't have an example, or actually they have an example, but uh, these equations can only be solved using computer because they are non-linear. Okay, so we'll stop here.